In this video we'll see how root 2 is an irrational number. Okay, so this we will prove by contradiction method. First, we contradiction method means something we will consider, but finally we will see that it is not following the property of rational number, so it will become irrational. Okay, let's suppose, for example, let us consider Hyderabad is not Delhi. How will prove that? First, we will consider Hyderabad is Delhi. Now, we will search all the properties of Delhi in Hyderabad. Like we will search Qutub Minar, we will search Red Fort, Parliament, and Raj Bhavan. Everything's in Hyderabad. So we will not find Red Fort and Qutub Minar and Parliament. So finally, we'll say since Hyderabad is not following the properties of Delhi, so Hyderabad is not equal to Delhi. Okay. So same we will do here. First, we consider let root 2 be a rational number. Since all rational number we can express as p by q form, so we will write that. Therefore, root 2 we can express as p by q form. Now, squaring both side, what we get? We get root 2 whole square is equal to p square by q square. Since square will cancel our square root, so will be 2 is equal to p square by q square, implies that q square we will send left side, then p square by 2. Okay, now left side integer, right side must be integer, so it means we here one more thing we have to write. We have p and q are co-prime. I mean their SCF is 1. There is no common factor between p and q, where p and q are co-prime. Co-prime measurement, their SCF is 1. There is no common factor between p and q. Okay, and p and q are integers also. Okay, now so 2 will divide, since left hand side integer, so right hand side must be integer. It means 2 divides p square completely. It mean, I can write here, it means 2 divides p square. Therefore 2 also divide p only, because 2 is a prime number. Okay, 2 dividing p squares, 2 also it will divide p alone. So it means, therefore we can write, it means p by 2 is equal to some constant k we are getting, implies that p is equal to 2k. We can put in equation number 1. That is our equation number 1. This one, that is q square is equal to p square by 2. Now after that, q square, in place of p we will put 2k whole square by 2 equal to 4k square by 2. 2 to the, so q square is equal to 2k square. Okay, so therefore q square by 2 is equal to k square. Okay, now implies that, now right side again integer, right side left hand side must be integer, so it means 2 divides q square. Therefore 2 also divide q. 2 also divide q. Okay, so from statement number 3 and statement number 2, 2 also divide q. This is statement number 2, because already we have considered question number 1. From 2 and 3 we are observing, from statement number 2 and 3 we are observing, from 2 and 3, 2 divides q, 2 divides p, means 2 is a common factor of p and q, which is not possible because p and q are co-prime. From 2 and 3, 2 is a common factor of P and Q, which is not possible because it is a co-prime, which is not possible, which is not possible. Since which is not possible, therefore, where is our mistake? Our assumption is wrong. Therefore, our assumption is wrong. Therefore, our assumption is wrong. Then what is the right assumption? Hence, assumption is root 2 is irrational. So anything that is not rational automatically that will comes under irrational. Okay. So thank you very much. It's all about root 2. In the same way we can prove root 3 is an irrational number, root 5 is an irrational number. Okay. Thank you very much.